Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through some special types of angles involving parallel lines. Before we get to the angles, we better understand what parallel lines means. So we say two lines are parallel if they never meet. Basically, they're going in the exact same direction. So remember, lines go on forever in both directions. This is a line, it has two arrows, it doesn't start, it doesn't end. So I could easily draw another line like this. So these two lines are parallel because even if they went on forever and ever, they would never meet. Okay, well, they should be parallel. You know, obviously my drawing won't be perfect. But the idea here is these lines go on forever, they will never meet. Now, usually we give them a symbol like this, a little arrow on the line to indicate that they're parallel. So that, in a question, tells you that lines are parallel. They will never meet. So we're looking at what happens when these two parallel lines are cut by the same line or line segment. So this thing here, red, is called a transversal. It cuts parallel lines. So we're going to learn about three types of angles in parallel lines. So the first type that we're going to look at are called co-interior angles. So co-interior, well, co means they're sort of like together, and interior means they're inside the parallel lines. Co-interior angles make a C shape like this, and they're inside the C, or it can be a back to front C. So in either case, the back to front C would be like this. They're both inside the parallel lines on the same side of the transversal. So if we go to our angles and parallel lines, this angle here and this angle here, they are co-interior. So we can see that they are marked by a back to front C like that. So these two angles are supplementary, meaning they add to 180 degrees. So if the green one was, say, 60, then the yellow one would be 120. If the green one was 150, the yellow one would be 30. They must add to 180 degrees. I know that's a bit tricky since they don't actually form a straight line. But of course, these are not the only pair of co-interior angles on the parallel line. So I'm going to rub this out and we're going to find the second pair. So, of course, this angle here and this angle here, they are also co-interior. So these are enclosed by a C that's sort of going the right way. That's what we mean by C shape, okay? So once again, they are supplementary. They add to 180 degrees. If the top one, the yellow one, is 10 degrees and the green's 170, they add to 180. So we're going to now look at the second type of angle. Please pause and copy this down if you need. So the second type of angles we're going to look at are called alternate angles. So what's the deal here? Well, let's say I have this angle here and this angle here. So these are not alternate, they're co-interior. So if I told you that this angle here was, say, 80 degrees, then this angle here has to be 100, right? Because they have to add to 180. But hang on a minute, this angle here and this angle here, they're supplementary. They add to 180 degrees. So this angle here must be 80 degrees. Similarly, this angle here must be 100 degrees because they add to 180. So what we have here is these two angles in green are equal, and these two angles in yellow are equal. So the two yellow angles are alternate to each other, and the two green angles are alternate to each other. So, of course, if you look at the two yellow angles, they're enclosed by a Z. Alternate angles have a Z shape. So they're on alternate sides of the transversal. So, of course, the green angles are also a Z shape, except it's more of a back to front Z that I'll draw here in red, okay? So alternate angles are equal and they make a Z shape. Let's look at the third type of angle. Once again, please pause and copy down if you need. So corresponding angles actually make an F shape. So once again, let's go back to our co-interior angles. This angle here and this angle here, they are co-interior. So if this angle here was, say, 70 degrees, this angle would have to be 110 degrees. But of course, 110 degrees, these two angles are supplementary as well. So if this angle in yellow was 110, this angle here in green that I'm colouring in now must be 70. Note the two angles here in green are equal. So they are said to be corresponding. So they make an F shape, but sometimes it's an upside down F. So this one here is an upside down F that encloses them. But hey, if this angle here is 70 degrees, this angle here that I'm going to colour in yellow, that must be 180 minus 70, that must be 110. Because these two angles are supplementary, they add to 180. So those two angles coloured in yellow are corresponding to each other. So if those angles are 70 and 110, we know, of course, that this angle here must be 110 as well. It's vertically opposite the other 110 degrees. It's also supplementary to the green angle. So that means that this angle here must be 70 degrees because it is supplementary to the 110. So if we keep going like this, we'll see we've got an angle here that's 110. And we've got angle here that will be 70. So what actually happens is when you have angles in parallel lines, you can see there are 8 angles and they come in groups of 4. 4 of them are 70 for 110. So these two angles are said to be corresponding to each other, just as these two angles are corresponding to each other, just as these two angles are corresponding to each other. They're all corresponding angles. There's actually 4 pairs of corresponding angles. So they're all enclosed by an F shape. So if we look at, say, this angle and this angle, they're enclosed by an F that goes like that. So the F can be upside down or backwards or whatever. So now we're going to do some examples where we're finding unknown angles. Please pause and copy this down if you need. So let's look at this diagram here. We're asked to find x. Well, we have parallel lines. We know they're parallel because of this here. So this line here and this line here are parallel. So when the lines are parallel, alternate angles are equal. This angle and this angle are enclosed by the z. They are alternate, so they must be equal, and x is equal to 80 degrees. So let's say this angle here is 120 degrees. This time we're going to find 2 angles. So we have to look, do we have co-interior corresponding angles or alternate angles or what? So the angle that we know 120 and x, they are enclosed by the c. So here, these two angles are co-interior. So remember, co-interior angles are not equal. Alternate and corresponding angles are equal. Co-interior angles are not. Co-interior angles add to 180 degrees because they're supplementary. So x is, so what do we add to 120 to get to 180 is 60 degrees. Now what we need to do is we need to, in brackets, write a reason. Why is x 60 degrees? How do we know that? So we know because they're co-interior. That's all we need to say. So I found x. What's y? Well, y, this is what we did last time. Y and x are facing each other. They are equal because they are vertically opposite. So I would just write y equals 60 degrees, and the reason, vert op means vertically opposite. You can write it a little simpler. So in the first one, they were both equal to 80 degrees because they're alternate. Second one, we had some co-interior angles. So sometimes we'll have the parallel lines going the other way. So here they're vertical, the two parallel lines, whereas they were horizontal before. So if I tell you that this angle here is 130 degrees and I ask you to find z, you have to decide, do we have alternate, corresponding, or co-interior? Well, here we have the F shape. Corresponding angles, these two are, they are equal. So we just write z equals 130 degrees. And of course, the reason is they are corresponding. So these will help us find unknown angles. So let's look at a few harder examples. So let's look at this diagram here saying I have 2 parallel lines and I want to find y. So this one is a little more challenging. The reason is y and this 77 degree angle, they are not corresponding, they're not vertically opposite, they're not alternate, they're not co-interior. What I have to do is I have to find another angle first before I find y. So I need to refer to these angles, and I've labeled points A, B, C, D, E, and F. So A is that point, B, C, they're of course all points. So let's look at what, y is corresponding to or whatever. So I know, for example, that y would be equal to this angle here. The reason is they are vertically opposite. So if I could find that angle marked in red, I could find y. Well, that's handy because that angle marked in red and this angle are corresponding. So I need to write and inform you that this angle here is 77 degrees. So what am I going to call it? Well, it doesn't have a pronumeral. Luckily, we know how to label angles. We have C to B to E. So I'm going to label that angle in red CBE. So that angle is equal to 77 degrees. Once again, I need a reason in brackets. And the reason is it's corresponding to that angle that's marked 77 degrees. This angle and this angle are corresponding, so they must be equal. So therefore, y is also 77 degrees because it is vertically opposite that angle I marked in red. So that's easy. Now we're going to look at a really hard example where you have to construct a line. So here we're trying to find the value of angle x. We have two angles marked, one's 106 and one's 121. Problem is, x is neither co-interior, alternate, corresponding, vertically opposite. It's none of that with any of the angles that are marked. The problem is we can't just find another angle that is corresponding or alternate to x as it is. So what we need to do in this case is we actually need to construct a line here that is parallel to the two red lines. I'm sorry for my poor drawing, but this line here is parallel because now I will be able to find this angle here very easily, and I will be able to find this angle here. Okay, so what I need to do is I need to find a few more angles. So let's look at this angle here. So that angle there is going to be equal to 106 degrees because it is alternate to the other one that is marked. Okay, so let's look at this 121 degree angle and the angle that's part of x. Well, I know that they are also alternate. This angle here is 121 degrees because it's alternate to the other angle marked 120 degrees. Now that I have this extra parallel line. So x was this whole angle here. X is equal to 106 plus 121, which is 227 degrees. The whole reason being alternate angles. So that was a slightly harder one because we had to construct our own line. So remember, co-interior angles, supplementary, not necessarily equal, C shape. Alternate angles, Z shape, they are equal. Corresponding angles, F shape, they are also equal. This is when you have two parallel lines cut by a transversal. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.